Welcome to part 2 of this lesson, where we'll now be dealing with inequalities. And as you can see, I've written the same question out twice, and I'm going to be showing you 2 ways to go about it. So we have option 1 and we have option 2. So at the end of this lesson, you might want to reflect upon which way you found most intuitive and the easiest. So going forward, you can utilize that method, but it's also good just to know both of them as well. So let's get stuck into it. So here we have the inequality of 4 to the x is less than or equal to 10. Now for this first option, what we're going to do is we're going to sketch it. So this first option really revolves around sketching what we're doing. So I'm going to come here and I'm first going to sketch out 4 to the x. I know that's going to look something like this. So this is y equals 4 to the x. And then I'm going to sketch 10. So that's just going to be a straight line. Let's say it's here. This is not to scale at all. So this is y equals 10. Perfect. Now, let's just really consider what this is asking us. It's saying, where is my red line less than or equal to my blue line? So where is my red line less than or equal to my blue line? Obviously, it's going to be less than when it's underneath it. So I'm looking at this region right here. So it stops obviously where they intersect. So to answer this, through my first method, if I can find the intersection spot, I can simply say everywhere to the left of that intersection spot is going to make this statement true. So when my x values are to the left of this spot, let's really use really simple language, when my x value is to the left of this spot, it's going to be a true statement. So now I need to find that. So the first thing that I'm going to do is find intersection spot. Find intersection. Intersection. And we know that to find the intersection spot, you simply set your two things equal to each other. And that means we're treating this like an equation. So 4 to the x equals 10. Now to answer this, we use our knowledge of logs. So it's going to be simply x equals log. My base is 4. My argument is going to be 10. So that means when I come down here, this spot right here, the x value of the intersection spot is going to be log 4 to the 10. So now what I'm going to say is everywhere less than that x value, everywhere to the left of it, less than it, is going to make this statement true. Everywhere where it's going to be greater, all the x values greater than this, obviously my red line is going to be above it. So that means step 2 is simply going to be writing out my answer. So it's going to be x is less than or equal to log of 4 to the 10. And just like that, we have answered our question. So the real, not tricky part, but the part where people will get wrong is making a mistake as to which side, which direction their inequality is pointing. By sketching it, we have determined that it should be pointing this way. So that's the why we're sketching it. Okay, let's now go through option 2. So this is another way we can approach this problem. Now, this other way that we're going to do it is we're going to take the log of both sides. So I'm going to say take log. Now it can be taking the log of anything, but I'm just going to do log of 10 of both sides. Both sides. So that means it's going to be log of 10 to the 4x. Now remember, it's an inequality, that's important. Log of 10 to the 10. All right. Now I know, according to my third log law, that I can bring this x to the front here. So it's going to be x log of 10, 4 is less than log, now actually instead of writing log again, log 10 of 10, well, when my base and argument are the same, I know my answer is just going to be 1. Because this is saying 10 raised to what power is going to be 10? Obviously, the answer is going to be 1. Okay, now, this is where I want everyone to pause when we come to this step. Obviously, we want to get the x by itself. And to do that, we're going to have to divide by this number right here. We're going to divide both sides by log 10, 4. Now, whenever we divide across an inequality, we need to stop and think. If I'm dividing by a negative number, it's going to switch. If I'm dividing by a positive number, it's not going to switch. So that means we need to determine whether this is a positive or a negative number. Let's now come to the side where I've written some notes down. So this is really important. Note tells us that the log of a number greater than 1 must be positive, and the log of a number less than 1 must be negative. So right here I have log of 4. So because 4 is greater than 1, I know this is going to be a positive number, meaning when I divide across by it, it is not going to change my inequality. So it's simply going to be x is less than or equal to, my inequality stays the same, 1 over log of 10 to the 4. So that's important. We're going to see another example where things are going to be different, but for the time being, it's important for you to realize that you need to determine whether or not what you're dividing or timesing, remember both of those can switch the inequality, you have to determine whether or not it's positive or negative. So that means this is going to be my answer. X is less than 1 over 10 to the 4. Let's now zoom out for a second and look at the two answers that we got. So the first answer that we got was x is less than or equal to log 4 to the 10, and now we've got x is less than or equal to 1 over log 10 to the 4. So as you can see, for these to be true, this value and this value must be the same. See, here we have log 4 to the 10, here we have log 10 to the 4, but it's the reciprocal of it. And this comes down to another rule that we need to make sure we know. So here's some more notes, and here's a rule that tells us that log x to the y is equal to 1 over log y to the x, which means that these two right here are the same. My base and argument have been switched, but because I have the reciprocal, it's the same. If I was to prove this to you, so let me give you a proof that this is true, but use some simpler examples. So if I was to give you a proof, so this isn't a strict like mathematical proof, it's more of an example. I shouldn't use the word proof, but it's already there and I can't be bothered rubbing it out. Okay, so if I have log of 4 to the 64, that should be equal to 1 over log 64 to the 4. So if this right here is true, this should be true because all I've done is switched my base and my argument and made 1 over it. So let's reflect on this. Log 4 to the 64, what's that equal to? Well, all that is saying, if I can just do some messy notes up here, 4 to the what power is 64? Obviously, it has to be 3. 4 to the 3 is 64. So that means my answer to this is 3. Then we come over here. Well, now we have 1 over log 64 and 4. Well, this is saying, let me do it up here, 64 raised to what power is going to be 4? Well, obviously, it's going to have to be a cube root, right? The cube root of 64 is 4, which means that x is going to be 1/3. So if I was to put 1/3 into this spot right here, I'm going to get 1 over 3, which is 3 equals 3. So look, it checks out. This rule is true. So therefore, what we see here is accurate. Log 4, 10 is the same as 1 over log 10, 4. That's how you answer the first one. Hopefully everything there made sense. Let's now move on to our second example, where we're going to be seeing our two options in play again. So let's first do it with our first option. So remember, we're first going to sketch it. And again, this is where you need to really stop and think, all right, I'm sketching 0.4 to the x. I know because my base is less than 1, it's going to be reflected across my y-axis. So it's going to look like this. So it's going to be y equals 0.4 to the x, and then I'm going to sketch this, y equals 5, which will simply be this. There we go, y equals 5. This question is asking me, actually, can I change it a bit? I want to draw this line higher up, just so I think it would be a bit clearer if it's up here. There we go, y equals 5. Again, this is not to scale in any sense. All right, so this is y equals 5. Now let's read this. This is saying, where is my red line less than my blue line? So obviously less than is just underneath it. So I'm looking at this region right here. So to solve this, what I'm going to do is I'm going to find my intersection point, find the x value for it, and then it's just going to be everywhere to the right of that, which will satisfy this answer. So when my x is greater than whatever this value is, it's going to be true. Okay, so let's give this a go. So step 1, is going to be find intersection. And to do that, we set both of them equal to each other. So it's going to be 0.4 to the x is equal to 5. Now we use our knowledge of logs to answer this. So this is going to be x is equal to log 0.4 to the 5, which means this x value right here is going to be log 0.45, which means our second part of this answer is simply going to say, well, according to this graph, x has to be greater than this x value right here, log 0.45, in order for this statement to be true. So as you can see here, really take note that our inequality has switched. And by drawing this graph, we've been able to determine that. We've been able to see, hey, it's going to have to switch because now it's going to have to be greater than this value for this to be true. Hopefully that makes sense to you. Let's now go through our second way of doing this question. So our second way, again, is taking the log of both sides. So what I'm going to do is take the log of 10 of both sides. So that means I'm going to be left with log 10 of 0.4 to the x is less than, remember we're dealing with inequalities for this second one. Well, we're dealing with inequalities everywhere. You're just going to make sure you write it down. And then log 10 to the 5. Then I can bring my x to the front. X of log 10, 0.4 is less than log, whoops, that's an ugly G. Log, whoop, my computer's starting to freak out a bit. Log 10 to the 5. All right, now, what are we about to do? If I could jump up and down right now to get your attention, I would. We're about to divide across an inequality, which means we need to stop and think. We need to stop and think. What do we need to think about? We need to think whether this is a positive or a negative number, because if it's going to be negative, it's going to have some serious repercussions. So let's go over here and remind ourselves of something. The log of a number greater than 1 must be positive. We know that. The log of a number less than 1 must be negative. Look. And 0.4 is less than 1, which means this is negative. This is related to log law 4, which is this. So if you can see here, like if we look at this example, if I have a log of a half, well, that can become 2 negative 1. The negative 1 comes to the front. We're dealing with negatives. The take-home message is that the log of a number less than 1 must be negative, which means as we divide across by this number, my inequality is going to switch. So I come up here and I'm going to write x is greater than log of 10 to the 5 over log of 10 to the 0.4. That right there is going to be my answer. Let's now zoom out. Oh, my computer's freaking out a bit, but I've gotten too far in this video to stop now. So I'm just going to let it freak out. So that means that this right here, oh, it's freaking out everywhere. Okay, so that means this right here, this x is greater than log 0.4 to the 5. This must be the same as this. So log 0.4 to the 5 is equal to log of 10 to the 5 over log of 10 to 0.4. We saw this in the first part of this video, where the very first question that we went through. I'm really annoyed that my computer now decided to freak out, but I'm not going to re-record this. All right. So that is proving this law right here, that log a to the x equals log b to the x over log b to the a. So that right there is showing that, but we've already seen it. I apologize that my computer freaked out here, but I've re-recorded this too many times to do it again. I'm going to go crazy if I re-record it again. Okay, hopefully that made sense, and I'll see you in class.